Now, thixotropy is in pseudoplastic materials also, as explained previously. All the examples are of pseudoplastic materials. Thixotropy can also be in plastic materials, or you can say viscoplastic materials, because viscoplastic materials are those which after yields value behave similar to pseudoplastic materials. So thixotropy can be in plastic or viscoplastic materials. Now when in plastic materials or viscoplastic materials, it behaves via three phenomena. One, so as you already know that the rheogram for plastic material do not start from the point of origin, it starts from somewhat again, which is called as yields value. Above yields value the graph starts. Now there can be three cases. First one, or A, is that the down curve is lower than the up curve. This is up curve. The down curve is lower than the up curve, but yields value is same. Fine. This is A case. The B case can be the down curve is lower than the up curve, but yields value is decreased. This type of materials are called as false materials or false plastic materials. Now there is third category also, when the down curve is less than up curve, but it starts from the point of origin. This means there is no yields value. So after this, material start behaving as a pseudoplastic material. So three cases may be there, A, B and C. A, there is no change in yields value of the plastic material showing thixotropic behavior, or there will be decrease in yields value, or there will be complete loss of yields value in the case of plastic materials. Otherwise, thixotropy is a phenomena which is very useful, say for preparation of suspension. Now you will assume a suspension which is prepared by a thixotropy. It is viscous. As you know that due to viscosity, the rate of sedimentation will be low. When you shake it, then what happens to the suspension? It becomes pourable because viscosity decreases. When it becomes pourable, you can easily consume it via a spoon or via a container. Then when you keep it at rest, slowly it regains its original viscosity, because of which the sedimentation, which is the problem for suspensions, do not take place, because suspension is now your viscous. And this whole phenomena which occurs because of either pseudoplasticity or thixotropy is called as controlled flocculation. Thank you. Now we will discuss about specialized thixotropic systems. The two specialized thixotropic systems are bulge and spur. Now these specialized thixotropic systems are changes which occur sometimes when a plastic thixotropic material is there. Now what happens in the bulge? In materials such as bentonite gel having a concentration of 10 to 15%, particularly called as bentonite magma, what happens when stress is applied? Then because of this stress, initially there is swelling of the bentonite. So instead of this original curve, there is protrusion in the curve which is called as bulge. Whole other curve behaves normally, but initially on application of force, there is swelling of bentonite magmas, and this swelling of bentonite due to formation of house of card arrangement is called as bulge. Spur is also another type of specialized system which we see especially in some kind of highly structured products such as highly structured procaine penicillin gel. When such gel is subjected to stress, so such gel has high yields value. There is no movement till value reaches this value, which is known as Y. In this case, it is called as spur value. So yields value is called as spur value. But when force reaches here, suddenly the structure, the 3D structure of the procaine penicillin gel breaks up suddenly, and there is rapid decrease in the viscosity leading to formation of a spur. Fine. So instead of a curve which has to become somewhere like this, there is a downward protrusion in the curve and then it follows a normal curve. So changes or deviations from the normal curve, if there is swelling, it is called as bulge. If there is downward protrusion, it is called as spur. And these are demonstrated by highly specialized structures. The bulges by the bentonite magmas and spur by the protein penicillin gel. Friends, now we will discuss about anti-thixotropy or negative thixotropic systems. Now, as previously told, they are quite similar to dilated materials. Now, what are dilated materials? Dilated materials are shear thickening systems whose viscosity increases on application of stress. In case of anti-thixotropic systems, on application of stress, their viscosity increases, and when stress is removed or decreased, then they regain its original viscosity, but after a time lag. Now, this is anti-thixotropic system. So, the initial portion of the graph is same as that of dilated material, which is known as up curve. In case of dilated material, the regain is instantaneously and only single line is there. But in case of anti-thixotropic system, they have a down curve, and down curve is always on the upside of the up curve. This means at a same shear value, the stress required for the down curve is more as compared to that required by the up curve. This means at every point, the viscosity of down curve is greater than the viscosity of up curve. So this can be understandable by a simple example. So now from 1, the viscosity is changing to 10. Now the similar but just opposite phenomena we have done in thixotropic systems from 10 to 1. Now here there is increase in viscosity. Now viscosity decreases, but before coming to 1, it stops. Fine. Actually, if more time is there, it will reach 1 also. So this is just a hypothetical representation that viscosity is coming back again, but since it is slow, so if we are taking same point, at the same point, the viscosity of the up curve is always less than that of down curve. This is represented by this. Now again, there is a hysteresis loop which indicates the amount of structural breakdown. Both these up curve and down curve are not superimposable, similar to thixotropy. So characteristics are quite similar to thixotropy, but all the process is opposite. Now if we see that, again important point, down curve is always above up curve. So down curve is always greater than the up curve in case of anti-thixotropic systems. Since they belong to dilatant family, so they starts from the point of origin. Again, the example is shown by flocculated suspensions with low solid content. So the flocculated suspensions containing very low solid from 1 to 10% show this type of behavior. An example is magnesia magma. The same example I have told you in rheopectic systems also, because literature says that, few literature says that rheopexy is similar to anti-thixotropy. However, difference I have already told you, rheopexy is rearrangement or rebuilding, whereas anti-thixotropy is deformation. That is the major difference between anti-thixotropy and rheopectic systems. The negative rheopexy is rheopexy applied to anti-thixotropic systems. So by any means, if we are able to reduce this time lag, if we are reducing this time lag by application of small forces, tumbling motion, rolling motion, this is called as negative rheopexy. Fine. So hope I am able to understand you all the phenomena of anti-thixotropy or negative thixotropy along with negative rheopexy. Both of them belong to the family of dilatancy.